All right, these are the second day of the notes for this week, week 5. These ones are a little bit trickier than the previous ones, but they're not too bad. So let's get going. So it says prisms, pyramids, cylinders, and cones. So it says the volumes of prisms, pyramids, cylinders, and cones are determined using the area of their bases and the heights. So the area of their bases and their heights, what they'll often do is they'll use the capital letter B to represent the area of the base. So you can see these formulas written in a couple different ways. Let me make sure I'm not off the screen. No, I'm not. Okay. All right. So first you need to know what a prism is. A prism is a rectangular solid. Something like such. So that's a prism. It's like a box. A pyramid, it's like the standard pyramid that you think of in Egypt. A cylinder is like a can. And then a cone is like your standard ice cream cone. All right. So there's a kind of cool relationship that happens, which is that when a prism and a pyramid have the same base area and the same height, the volume of the pyramid will be 1/3 the volume of the prism. What does that mean? Okay, that means that if this base is the same as this base and the height is the same as this height, you could fit 3 of these. Like if you filled this up with water, you could fit 3 of these into a box of the same base and height. And the same thing happens with cylinders. If they have the same base, cylinders and cones, and the same height, you could fit 3 cones into the cylinder. So it's pretty cool. And so we measure volume in cubic inches because if you think about volume, what volume is like if I were putting little cube dice in here, like little 1 by 1 by 1 cubes, and layering them, it would be how many of the cubes could fit in there. And so they say, the next thing they say is the same relationship is true for cylinders and cones. All right, so let's just talk about capital B really quickly. So capital B, B is the area of the base. So if you're talking about a rectangular base, it would be length times width. So B would be the length times the width, which would be in inches squared. But if you're talking about like a cylinder, the base would be a circle. So B would be pi r squared. So they could write this volume formula in 2 different ways. So they could say the volume of a prism is capital B times H, or they could say that the volume is the length times the width times the height, because B is length times width. And the same thing here, they could replace B with length times width times height. So it could be that, or the volume would be 1/3 the length times the width times the height. And then with a cylinder, right, this could be represented the r squared h, or sorry, the r squared times pi. Remember to find the area of the circle, it's pi r squared, so they could replace this pi r squared with capital B, so it would still be base times height. And so you can see they're the same formula, but this time B would not be length times width because it's not a square or a rectangle, it's a circle. And so again, they could write this as volume equals 1/3 the base times the height. All right, let's do an example. First example, it says a prism. Okay, so first we need to know what formula we're working with. So we have a prism. A prism has a base, that's capital B, with an area of 5 square inches. So capital B equals 5 inches squared. Whoops, not cubed, squared. Excuse me. And a volume, so that's V, equals 30 inches cubed. So 30 inches cubed. It says, what is the volume? Always make sure you're reading it to figure out which variable you're solving for. What is the volume of a pyramid? So we're going to be using this formula for volume, and we're going to be looking for V of a pyramid with the same base area and the same height. So what we would need to know to find the pyramid is we need to know how to, either the height of this prism, which is what they solve for here, or we actually could just use the formula directly. So what I know is that the volume of this figure is 3 times larger than the volume of this figure. So what I could do is I could say the volume is 30 inches cubed, and the other volume is 1/3 of this volume because they have the same base and height. So I could say that the volume of the prism is 1/3 the volume of the rectangle, which would be 1/3 of 30, I got ahead of myself, and 1/3 of 30 is 10. So this would be 10, and remember we're in inches cubed, this was inches cubed, so 10 inches cubed. This is how I would do this problem. All right, they did it slightly differently. So what they did is they said, okay, they want us to find the height of the prism using the volume formula. So we're going to use the prism formula and get the height. So we plugged in the volume's 30, and they plugged in the base was 5. And then they divided both sides by 5, and they get that the height equals 6. And then what they did is they substitute the values for B and H into the formula for the pyramid. So they say the volume equals 1/3 the base times the height. The base is 5. The height is 6. 5 times 6 is 30. 1/3 of 30 is 10. I like my method, but if you liked their method, you can certainly use that one as well. And let's try the next one. All right, this time it says a cylinder, right? So a cylinder, that means we're going to be using this guy. And it says the cylinder has a volume, V, of 24 pi centimeters cubed. So the volume is 24 pi. And then it says the height, H, is 2 centimeters. What is the radius? So we're looking for the radius of the cone. So we're going to be using this formula. What is the radius of the cone with the same volume and height as the cylinder? All right, so I'm going to go ahead and substitute the volume and the height into my my cone formula. So here's my cone formula. Volume equals 1/3 pi r squared h. So the volume was 24 pi, and the height was 2. All right, so next I'm going to kind of do this off to the side because they just show that it's 2/3, but I'll show you how they got that. So they said 24 pi is equal to 1/3 pi r squared times 2. Now remember, all of these are over 1, and so if I multiply the numerators and the denominators, this would become 2 over 3. So I have 24 pi equals 2 over 3 times pi, and then times r squared. Now what I would generally do next for my students is I would say, okay, my goal is to get r by itself. So I'm going to go ahead and divide both sides by pi, and my pi's will reduce. So I get 24 equals 2/3 times r squared. Now I could go ahead and multiply by the reciprocal, which is what they actually did right here. They multiplied both sides by the reciprocal. So I'm going to multiply by the reciprocal. So I'm going to multiply both sides by 3 over 2. Don't forget there's a 1 here. So the 2's will reduce, and so will the 3's. The 2's will reduce here. 2 goes into 24 12 times. 3 times 12 is 36, and that's supposed to equal r squared. To find r, though, I would need to square root both sides. And so I get r equals the square root of 36, which is 6. And we are working in centimeters, so the radius is 6 centimeters. There's another way to do this problem, right? You could go ahead and use the cylinder formula and find the height and then plug it in if you prefer. I'm going to go ahead and do that method as well. So I could say the volume is equal to pi r squared times the height. The volume that they gave me was 24 pi, and that would be pi r squared h. H was 2, so pi r squared times 2. I could divide both sides by 2. Actually, I could divide both sides by 2 pi. Now I'm not working with fractions, so here the pi's will cancel, and then that would be 12 equals r squared. And then what I could do is plug this value back into the volume formula. So the volume of the cylinder, or sorry, the cone is equal to 1/3 pi r squared h, which is 1/3 pi 12 squared times the height. That's 144. 144 times 2, so 1/3 pi times 144 times 2. 144 times 2 is 288. Let me make sure I'm not going off the screen. No, I'm not. So this would be 288 times pi, and then 1/3 is out front. And then 1/3 of 288 is 96. So the volume equals 96 pi. And then I could substitute this in right here and find my radius. So I think their method was a little more straightforward, but there are multiple ways you could do it. All right. Let's move along. So here's some guided practice. All right, number 1, it says a prism. So let's go ahead and make sure you have your formulas right in front of you. So a prism, which is going to be the volume equals the base times the height. Has a base with an area of 8 square units. Okay, so that means that B equals 8 units squared. The height of 6 units, so H is 6 units. What is the height of a pyramid with the same volume and base area? So we're looking for the height of a pyramid. All right, so a pyramid is volume equals 1/3 the base times the height. And it says it has the same volume, so the volumes are equal. Volume is equal to volume. And it says it has the same base area. So that means the base is equal to the base. So that does not necessarily mean that the heights are equal, because if that were true, if these are equal and these are equal, this one, right, the height must have a relationship between this height, but they're not the same. Okay. All right, so they're walking us through it. They say find the volume by using the formula for a prism. So volume equals base times height, right? So the base was 8 and the height was 6. So 8 times 6, which is, and this is inches, or sorry, units squared, and this is units. So that would be 48 units cubed. And then once we know the volume, it says the volumes are equal. So it says to substitute the values of B and V into the formula for a pyramid. So here's my pyramid formula. They have the same volume. That means that this is 48 units cubed. And they have the same base, which means that this is 8 units squared. And then to solve for H, I'm going to do that over here. So I've got 48 units cubed equals 1/3 times 8 units squared times H. Let me make sure I'm not going off the screen. I'm famous for that. No, I'm not. Okay. So remember, I'm solving for H. The units squared is just, it's not an unknown. It's like inches, right? So I'm going to divide both sides by 8 units squared. So those will reduce. 8 goes into 48 6 times. Units and units cubed, this will give me 1 unit. So 6 units is equal to 1/3 of the height. And then to find the height, I would multiply both sides by 3. So I'd get 18 units is equal to the height. And there we go. Now, it makes sense if you understand that they have the same volume and the same base, that this height must be 3 times as big as this height. All right, next example. It says a cone, so it has a base with a radius of 2, so that means that R is 2, and we're going to be working with cone formulas. So the cone formula, sorry about my dog, is the volume equals 1/3 pi r squared h. And it says it has a height of 3, so h equals 3. And this is centimeters, and this is centimeters. What is the height? So we're going to be looking for height of a cylinder. So we're going to be using the cylinder formula, which is pi r squared h, with the same volume and base radius. So that means that my volume is the same and my radius is the same. Clearly this must have a height then that's 3 times larger than this height. All right, so they walk us through it. So they say first find the volume by using the volume for a cone. So we're going to substitute in R, which is 2 centimeters, and H, which is 3 centimeters. So 2 centimeters squared, and then 3 centimeters. This is 4 centimeters squared times 3 centimeters. That's 12 centimeters cubed. 12 centimeters cubed, and then times pi. And then we're taking 1/3 of that. So they don't show that step, but I'm doing it off to the side here. 3 reduces, and we get 4 pi centimeters cubed. All right, next, after we find that, now we're going to substitute the values for R and V into the formula for a cylinder. So I know V, right, they have the same volume. So that means that the volume is 4 pi centimeters cubed, and the radius is still 2 centimeters. And then off to the side, so I have 4 pi centimeters cubed equals, this is 2 squared, which is 4 pi times the height, and we're in centimeters squared. All right, so I'm going to divide everything by 4 pi centimeters squared. So the 4 is reduced, the pi is reduced, the 4 is reduced, the pi is reduced. Here the centimeters reduce. Here the centimeters reduced to a centimeter. There's nothing left but a 1, right? Everything reduced to a 1. So 1 centimeter must be the height, and that makes sense. I said that the height here must be 3 times the height here for them to have the same volume. And so if this is a 3, this must be a 1. So 1 centimeter. All right, one more example. I believe, let me triple check that. I don't want to say there's one more and then there's actually 2 more. Oh no, there's 2 more. 2 more examples. All right, so it says a square prism and a square pyramid have the same volume and height. So what it means to be a square prism is that the base is a square. And a square pyramid, it's the same thing. All right, so they says it has the same volume and height. If the area of the base of the prism is 12 inches squared, what is the area of the base of the pyramid? So again, we're going to be using pyramid and volume, the volume of a pyramid and the volume of a prism. So it says first write the formulas for the volume of a prism and cylinder. Oh, I don't think that they meant cylinder. They meant prism. Substituting 12 for the base of the prism. I'm sorry, they meant pyramid. My bad. Pyramid. Okay, so the volume is the capital B, right, times the height. And in this case, it says that the area of the base of the prism is 12. So the volume is equal to 12H.